Welcome to the PreAlgebra Do Now 31.1 video key, and here we go. So we're going to use the Pythagorean theorem to calculate the length of the missing side. So the Pythagorean theorem, as you probably remember, is a squared plus b squared equals c squared, where a and b are the two legs of a right triangle, and C is the hypotenuse. So the hypotenuse is the side that is longest and is opposite the right angle. So this is C. This could be, doesn't matter which one of these is A or B, but if I declare that that angle is A, then this side is side A, and then this angle, if I call this angle B, then this side is side B, and then that means this angle is angle C. So there's a little convention of labeling, but it is somewhat arbitrary which one of these is A or B, but this one has to be C. The hypotenuse has to be C. So what we need to do is we need to replace the letters with the numbers that are associated with them. So B is going to be 1, so that's 1 squared, and C is going to be 2, so that's 2 squared, and that will equal, and that will be plus A squared. Cool. Now that means that A squared plus 1 equals 4, so A squared plus 1 equals 4, and then we can subtract 1 from both sides, and A squared will now equal 3. Okay, that'll equal 3. And then to figure out what A is, we get the square root of both sides. Okay, so A is going to be plus or minus the square root of 3, but we're going to discard as extraneous the negative version. So plus or minus the square root of 3, which is two different numbers. That's the square root of 3, which is around 1.7321, or the negative of the square root of 3, which would be negative 1.7321 forever. All right, so what we're going to say is A is going to equal the square root of 3. So there we go. That's the answer. So that's the square root of 3. And that, by the way, this is an equilateral triangle that's been split in half, okay, because that's a 60-degree angle. This is half of a 60-degree angle. So there's another half of an equilateral triangle over here, which means that this is half of the normal side length, and this is an altitude of that equilateral triangle. So that gives us a relationship of 1 to the square root of 3 to 2. So the short side and the hypotenuse are going to have a 1 to 2 relationship, and the short side and the medium side, the longer leg, is going to have a 1 to root 3 relationship. So let's consider that in regard to this one. So over here, we're asked to figure out what C and B are. Well, based on the last thing, the C should be twice what this leg is. So C should be 5 times 2. This is 5 times 1, and this should be 5 times the square root of 3. And that's what they are. Okay, so